Hey everyone, thanks for joining us for the technical takeoff session, Optimization for Windows 365 and Azure Virtual Desktop, Intelligent IT Management. My name is Ben Murphy and I'm a product manager on the Windows 365 and Azure Virtual Desktop team. Joining me is a fellow product manager, Anusha Reddy.
Thanks, Ben. I want to reiterate our appreciation to all of you for taking some time with us today. We're excited to show some of our favorite management features for Windows 365 and Azure Virtual Desktop. Today, we're going to walk you through some key concepts and functionality for reporting and insights available in both Windows 365 and AVD to help provide the best experience for end users while being conscious of costs. First up on the agenda, I'll kick things off by showing how proactive alerts in Windows 365 makes it easy to monitor the health of your environment and being informed of critical issues before they affect your cloud PC users. Even better, I'll show you how to set up and configure these alerts to ensure your environment continues to stay healthy. Next, I would like to share some insights on how you can optimize license usage while keeping the overall cost of ownership to a minimum.
That tees up a conversation about our ability to maximize your flexibility through our resizing functionality. That, in turn, sets us up to introduce our first AI-based feature in Windows 365, a cloud PC recommendation system that's designed to identify if your cloud PCs are the correct size and whether they're being fully utilized. From there, we'll move to Azure Virtual Desktop and walk through how you can use some of the same concepts to identify how your session hosts are being used and how you can use our native monitoring with Azure Virtual Desktop Insights to understand how to use scaling plans to optimize your host pool efficiency.
Let's get started with our first management feature for the day, proactive alerts. This feature on Intune provides a consistent method to notify administrators about critical issues. Administrators have the flexibility to customize alerts and notifications based on their preferences to ensure proactive monitoring of the environment and, most importantly, take necessary actions to remediate those critical issues to minimize impact. As of August, Windows 365 alerts have been generally available, and we continue to add more alerting capabilities to enable admins with comprehensive insights to investigate and resolve those issues. I'll dive right into the demo. I'm on the alert overview page that shows all the alerts that an administrator can establish for resources such as Azure Network Connection, provisioning policy, image uploads, cloud PCs that aren't available, for cloud PCs in grace period. By clicking on the alert item, you get event summary flyout that provides more details of the impact and, most importantly, a call to action for a report or a failed alert page to gain deeper understanding about devices that are impacted. Clicking on the report link here will launch the failed alert event page. This offers additional information about the alert event so you can take necessary actions to resolve the issue. I will click on the cloud PC here. A flyout opens with additional details about the impact of this specific cloud PC that is placed in grace period. As an administrator, you can choose to either reprovision the cloud PC or end the grace period. Let me transition to show you how to configure these alert rules. Let me select the cloud PCs in grace period as an example here. You can define alerts for your preferences and the environment that you manage. You have the flexibility to customize and enable or disable the alert rules, including conditions, notifications, depending on your specific requirement. Before I conclude, I would like to highlight another important alerting capability for when cloud PCs are experiencing connectivity issues. It is very crucial to me as an administrator to be notified when my users are having trouble connecting to their cloud PCs. This is our latest alert functionality. The flyout provides comprehensive details, organization impact, and most importantly, a call to action for a report that provides deeper details about any device or user that may not be able to connect to their cloud PC. This view provides a deeper understanding of devices that may not be able to connect, the underlying cause, and effective remediation. What's special about this alert rule is, unlike other alert rules, you have the ability to define this and set thresholds for more than one condition, be it connection errors, host health checks, systemic errors, and also you have flexibility in customizing it specific to your needs. With this, I would like to conclude saying that the proactive alerts administrators can stay updated on issues affecting their environment, allowing them to take prompt and informed decisions to resolve problems as they come up. As a tenant administrator, it's crucial to have in-depth insights into utilization so I can optimize license usage, thereby reducing total cost of ownership. I would like to see whether devices assigned to users are being fully utilized or not. Cloud PC utilization is a feature that helps admins understand usage patterns and identify devices that are underutilized. We often hear from IT admins that number of assigned users far exceed the number of active users, and administrator always wants to optimize usage in their environment. They might do this by either downgrading or redeploying those unused or idle devices to new users without paying for incremental licenses. So let's see how this works seamlessly with Windows 365. Here I am on the Devices Overview page on Intune. Let me click on the Cloud PC Performance tab. This dashboard is a place where a Windows 365 administrator identifies devices with issues. Rather than sifting through the entire tenant, Cloud PC Performance is built with anomaly detection and highlights devices requiring immediate attention. Administrators also have a choice to dig deeper into details about specific devices identified with problems. You can also access these reports at an all-new Cloud PC Overview blade under Reports. For rest of my demo, I'll stay on this view. I can click on the Cloud PC Utilization Report title or the ellipsis to launch the unfiltered tenant level report. Clicking on the metrics will launch a filtered report. We provide a tenant level view to admins so they can view usage for devices to better optimize licenses. Clicking on the view report here, I see all insights for all the devices that I manage. I can view specific devices for a specific SKU type, enterprise, or frontline. I can spot underutilized devices. I can identify inactive users on devices for extended periods. So I can deprovision or downgrade licenses, making sure utilization is optimal. I can add these devices to my inventory or allow config changes for the existing ones. Let me pick an example here. I'm going to look at all the devices that were connected for less than 40 hours within the last 4 weeks. This pulls up devices that recorded low usage, matching the time frame I selected. Let me look at the top device here that is identified as connected for only 2 minutes. Maybe this is a perfect device that can be deallocated so I can add this to my inventory or allocate this to new users. Before I do that, I want to gather additional details on the performance and connectivity. For in-depth insights on specific device, you can click on the Cloud PC name, which will launch the session performance for this device for the last 7 and 28 days. With this, I would like to conclude by saying that with comprehensive usage insights, administrators can ensure optimal usage and also minimize costs.
Thanks, Anusha. I think that's a perfect segue into another Windows 365 feature that can help with optimization of your TCO and with performance improvements for end users. One of the key advantages of cloud PCs is the inherent flexibility to allow your workload to grow or shrink based on real user needs. With our updated Resize functionality, you can now dynamically increase or decrease the resources allocated to your cloud PCs. Note, though, that OS storage cannot be downsized. But that being said, let's see what that looks like. To start with, we'll show a demo of how you can perform a bulk resize operation on a group of Windows 365 Cloud PCs. There are a few ways you can do this depending on your configuration, but I'll show a case for Microsoft Intra ID group-based licenses. This walkthrough will cover how to resize an entire Intra group. Our usual advice is to set up one group per Windows 365 license type you own, as this makes configuration and organization easier down the line. First, we're going to search for a source group. We'll call this a source group because it has the users we want to resize from their current license to a new target license. In here, we're going to click on Members, and we're going to see who is in the group to make sure that we're applying our changes to the correct user set. Next, we'll click on Licenses, and we can see they're currently assigned a 2 vCPU, 4 gig, 256 gig of storage Cloud PC. Now we can check in the All Cloud PCs tab and see that they're actually provisioned. These are active devices right out there. So let's resize these devices. To do that, what we're going to do is start by going to the All Devices tab and selecting Bulk Device Actions. I then select Windows as the OS and Resize as my device action. This is going to prompt me with two selections. I have the option to pick a source size and a target size. In this case, it helps me make sure that I'm only resizing Cloud PCs of the size that I would like to change. So in this case, I'm going to pick the source size that I saw in my license area, and I'm going to pick an appropriate target size based off of my sizing. Now, what we're going to do is pick what devices this applies to. So I have the option of selecting them individually if I would like, or, and this is how we suggest that people do it, the ideal way is to select a group. So in this case, we'll go through, we'll search for the group that we specified earlier, we'll select it, and we'll note that the devices in that group are now in the scope of this bulk action. So this is all of the devices I'd like to take an action on. So let's go ahead and go to the next step. And from here, we're going to run a series of validation pre-checks to make sure that the devices are actually ready to resize. So if for some reason a device is not ready to resize, we will post an error. That'll give you some information about what you need to do if you need to take some action to allow it to resize. But in this case, everything appears to be ready to go. So from here, we're just about done. If I click that Create button, it's going to go out and it's going to start the activity, but not actually start the resize. In this case, as an admin, I need to assign the appropriate licenses to that group to actually start the resize process. So from here, I'm going to go back to Windows 365, and I'm going to go back to the All Cloud PCs view. And in this case, again, I'm going to search for that set of devices that I was working with previously. And it's going to display that those devices are in a resize pending license state. Now, I might have to refresh here, and we'll see that this now shows that they're just about ready for the resize action to take place. So to do that, I have to go back to my group, and this allows me to assign the appropriate license. Once I actually go back into the license menu here and add the licenses that I need in order to actually do the resize operation, it automatically starts, and that gets me into the actual resize action itself. So this assignment transacts, and you'll notice that I get dropped back into a state where devices are now being resized. So you'll notice the status goes into the resizing state. So the big question is, how do I know when resizing my Cloud PCs may be for the best? So that's where our next feature comes in. I mentioned earlier that a key goal is to try to optimize the total cost of ownership of the deployment. Another important goal that I may be interested in trying to optimize for is the performance that my end users get. To help make it easier to identify those opportunities, we've introduced Cloud PC recommendations. This is an AI-based mechanism that's designed to give you a quick view into whether devices are sized correctly or if they're being used at all. So key for this experience is that it's directly integrated into Intune. You don't really have to do anything to set it up. We are simply surfacing AI-driven insights to you. So how does that work? Well, it starts with a collection of platform data like VM resource consumption, like utilization, characteristics of users, and we feed those details into an evolving AI model where it's processed and insights are generated based on activity. Note that this model will continue to mature, so as we improve our recommendation system, you'll start to see additional details on what motivated the categorization of a particular device. Finally, the recommendations are output into our Cloud PC recommendations report, where you can view our specific advice on devices to resize or deallocate. So let's see it in action. So this is an overview of Cloud PC recommendations, an AI-powered feature for Windows 365 that's designed to allow you to optimize the performance and total cost of ownership of Cloud PCs. The idea is to try and identify devices that are right-sized, here shown in green, which means that they have the ideal resource configuration for a user. Or, in contrast, where they may be undersized, here shown in red. That means the device may not have the resources that a user needs to do their day-to-day activities. That could mean they have a poor user experience, application problems, or other issues. Now, if a device is oversized, shown in orange, that means the device has more resources than a user might need, and you have the option of downsizing for a cost savings. Finally, some devices may be underutilized, which means they aren't interacted with very frequently, or in some cases, aren't logged into at all, and those licenses can be reclaimed. So I have a few different mechanisms I can use to view this information, and really importantly, I have the ability to view this by device. So when I pick my device view, I have the ability to break out each individual Cloud PC, what category it falls into, and really importantly, a specific recommendation for a SKU that we feel like is more appropriate for the workload that that user has. So this gets me a really detailed view into what specific actions I need to take. I also have the option to view that by model. And in this case, it allows me to surface some key insights like whether or not certain SKUs are appropriate for my environment. So in my case, I have a handful of 2 vCPU configurations, but they tend to be undersized, meaning that maybe I need a new baseline. So these Cloud PC recommendations are AI-driven and give you a mechanism to make informed decisions about how to use that same resize functionality that we talked about to improve the performance of your environment and also save on costs. Now we're going to segue into an Azure Virtual Desktop topic that's very near and dear to my heart, and that's session host utilization and efficiency analysis. It sounds complicated, but really it's all about trying to understand when are people interacting with session hosts and what can you do to optimize your costs. So the really big question we want to answer here is this. Are scaling plans a good fit for my environment, and how do I identify if they are? So we'll walk specifically through how you do that, but the good news is you don't have to worry about doing any customization. You don't have to worry about third-party tool investments. This is all self-contained within our native monitoring solution, Azure Virtual Desktop Insights. So this gives you an inbuilt mechanism not only to do the initial planning, but also to validate that those scaling plans are working like you expect. So the process overall, we can take a look at that. And in this case, again, very similar to what we talked about before, starts with data. So we analyze utilization in order to find patterns about behaviors, about activity, in order to understand what we can do to make an appropriate scaling plan. Based off of that insight, we can then deploy that scaling plan, have appropriate ramp up and ramp down times configured, and then validate to make sure that that configuration does exactly what we think that it should. This sets us up for the ability to iteratively improve our environment. To start with, we open up our AVD Insights view, and you'll notice I'm looking across all of my host pools in this case. I'm using an at-scale view to get a sense of what's happening across my entire environment, and our starting point is the overview, which gives me some key insight about how my session hosts are used and my overall capacity. So I've got details like how many host pools do I have, what kind of session host capacity do I have, what kind of currently available capacity do I have, what kind of historical capacity do I have, things that are relevant for me to make a decision about whether or not I have the resources appropriate to support my users. But for our purposes, we're primarily going to focus on utilization. So our utilization reporting is split into a couple of different areas, and one of the important ones is the overall concurrency of user sessions. So Here, we note that we have a significant number of sessions throughout the day. However, we have a fair number that are actually idle. So what that means is that a user is not actively connected to a session. Instead, they've left a disconnected session open. So this means we could have an opportunity to set up a policy to start force logging people off after a period of inactivity. It is worth considering. Next, we can take a look at the overall efficiency of our session host usage. So in a multi-session scenario, one of the really important characteristics that we'd like to take a look at is effectively what kind of user density can I get, or how many users per core can I achieve? Generally, the higher this number is, the more optimal your environment is, depending on what it is that you're trying to do. But of course, your mileage might vary depending on what you're trying to configure for. The key for us, though, and this is really kind of the anchoring point for the planning for scaling plans, is to focus on session host activity over time. So the key thing is for us to identify, are there periods where we've got idle session hosts? So an idle host in this case is quite literally doing nothing. There is no one connected to it. There are no disconnected sessions. It is just occupying compute resource without really doing much in return. So the question is, what can we do about that? Here, we can identify, one, is that even something that I need to worry about? So in our case, actually, yes. We have plenty of periods where we have a significant number of session hosts that are idle in ordinarily periods that are off hours, which means we don't necessarily have to have them turned on. So this means we have a very good opportunity to configure a scaling plan, in this case, to optimize my costs by turning devices off when they're not in use and turning them back on when I'm ready to start ramping that workload up. So comparing when users are active, this session concurrency, and this overall session host activity, I can now complete that picture of a scaling plan and make use of it in order to optimize my environment. So we've given an overview of some existing features that can help you optimize your environment, but we continue to innovate and develop new features to make things easier, both for management and general insights about your environment. One of the things that I'm most personally excited about is intelligent management through expansion of AI-powered features. So I mentioned that we're introducing our first AI-powered feature, the Cloud PC recommendation system. We're also planning on creating an automated troubleshooting and problem remediation setup that will allow you to get insights into what the most important problems are in your environment and even provide mechanisms to automatically resolve those problems.
We continue to invest in enhancing experiences. One such feature is maintenance windows. Administrators will soon be able to define a preferred time to trigger device actions such as a bulk resize on cloud PCs with consistent notification support both in session and on Windows 365 app that enhances the end user experience and reduces administrator overhead.
And finally, we have a few Azure Virtual Desktop improvements that we're creating as well. One of the big ones is connection reliability analysis inbuilt into Azure Virtual Desktop Insights that will give you the ability to really pinpoint when and if disconnect events are impacting your users. Finally, we're also integrating scaling plan reporting into AVD. So that gives you the ability to, again, review some of the steps that we just talked about in the course of this session and ensure that your scaling plan is doing what you think that it should be and it's doing it successfully. Please do share your feedback with us. We always appreciate that.
On behalf of Ben and myself, I would like to thank you for taking time to join us today on this technical takeoff session.